Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. This is problem number 6 from the written answer section of the last exam MLC in the spring 2018 exam season, and practice problem for exam LTAM for July 13th, 2018. A defined benefit pension plan with two members, Finn and Oscar, provides for a pension benefit paid as a monthly whole life annuity due. The annual pension benefit is 1.7% of the final 1 year's salary for each year of service. You are given mortality follows the illustrative life table, assuming deaths are uniformly distributed between integer ages. Participants reaching age 64.5 retire at that time with probability 50%. All participants reaching age 65 in service retire immediately. There are no other retirements. There are no withdrawals from the plan other than by death or retirement. Interest rate is 6%. A double dot 64.5 upper 12 equals 9.5613. Salaries increase every year on January 1st. Future salary increases are assumed to be 2% per year. On January 1st, 2018, Finn is 25 years old. He is a new employee with no past service. His salary in 2018 is $60,000. On January 1st, 2018, Oscar is 64 years old and has 29 years of service. His salary in 2017 was $95,000 and in 2018 is $100,000. A. Calculate the projected replacement ratios for both Finn and Oscar, assuming that they each retire at exact age 65. B. Calculate the total accrued liability for the plan on January 1st, 2018 under the traditional unit credit method. C. Part 1. Calculate the normal cost under the traditional unit credit method for Finn. Part 2. Calculate the normal cost under the traditional unit credit method for Oscar. D. Part 1. Without further calculation, state with reasons whether the normal cost under the projected unit credit method will be greater or less than the traditional unit credit for Finn. Part 2. Without further calculation, state with reasons whether the normal cost under the projected unit credit will be greater or less than the traditional unit credit for Oscar. And here's the solution. Part A. We calculate the projected replacement ratios for both Finn and Oscar, assuming that they each retired at exact age 65. Upon retirement, Finn's annual pension benefit is 65 minus 25. He is a new employee now with age 25, and he will work until 65 under the assumptions presented. So 40 years times 1.7% for each year of service times the salary at age 64. And his replacement ratio will be this divided by the salary at age 64, and that's simply 40 times 1.7% or 68%. Upon retirement, Oscar's annual pension benefit is based on 30 years of service because he will add one more year by the time he retires, and his annual pension benefit is 30 times 0.017 or 1.7% times S64, and this divided by 64 is his replacement ratio, which is 30 times 1.7% or 51%. For Part B, the accrued liability for Finn is 0, while the accrued liability for Oscar is 29 years of service times 1.7% for each year times 95,000 salary, then multiplied by 1/2 probability of retiring at age 64.5 times the probability of being alive then, which is L64.5 over L64, times 1.06 to the minus 64.5 minus 64, that's the present value factor, times A double dot 64.5 upper 12, which is the cost per dollar of retirement benefit at that age. Now, of course, the 1/2 at the beginning refers to the probability of retiring at that age. And then there is another 1/2 for age 65 in the next formula, where we have that 1/2 times the probability of being alive at age 65, times discount factor, just 1 year discount, times the cost per dollar of paying a life annuity benefit as prescribed. So we need to figure out all the numbers in this, just plug them in and do the calculation. What is A double dot 65 up 12? We're not given that, but under UDD, that's equal to alpha of 12 times A double dot 65 minus beta of 12. All of these are given in the illustrative life table, and so we plug in those values, and we get approximately 9.4315511. L65 is given in the illustrative life table, so is L64. And A double dot 64.5 up 12 is actually given in the problem directly. And under UDD, L64.5 is the arithmetic average of L65 and L64. So we plug in those two values that we have from the table to get that. And so we calculate the pieces that we have here. 29 times 0.017 times 95,000, that's 46,835. 0.5 times the arithmetic average of L65 and L64 divided by L64 times 1.06 to a negative 1.5 times 9.5613, that's approximately 4.5980512. And then 0.5 times the ratio of L65 to L64 times 1.06 to a negative 1 times 9.4315511. And that comes out to be about 4.3619897. We combine these three numbers, so we multiply 46,000 times 46,835 times the sum of 4.5980512 and 4.369199897 and get approximately 419,643.52. For part C, part 1, we calculate normal cost under the traditional unit credit method for FIN. We use the standard recursive formula that the accrued liability at the year beginning plus normal cost is equal to the actuarial present value at the year beginning of mid-year exits plus actuarial present value of the accrued liability at the end of the year. In this case, there are no mid-year exits, and 1P25 times 1.06 to a negative 1 times accrued liability at the year end is equal to actually just actuarial present value of the benefits, which is at the beginning of the year, which is 60,000 based on current salary, times 0.017 times 1/2 probability of retiring at age 64.5, and all the familiar calculations that we just did, and then 0.5 times probability of retiring at age 65 times all the familiar numbers that we had. So what this comes down to is that we just credit 1 year, because this is the credit that he will have under traditional unit credit. It may at first surprise, but no, this is traditional unit credit, so we don't project anything into the future. He will have, the accrued liability will be for 1 year of service. And then we calculate all these numbers, 60,000 times 0.017, which is 1020. Then all the calculations for 64.5 age of retirement that we just did before. But specifically for the factors inside of parentheses, the first expression. And comes out to be about 0.38066672. And we do the calculation for the second factor, second expression inside the parentheses, and this comes out to be 0.61124, and then normal cost is that 1020 times the sum of the two expressions inside the parentheses, and this comes out to be 756.63. It's a relatively small number because it's only 1 year worth of service that this pays for. For part C, part 2, we calculate now the normal cost under the traditional unit credited for method for Oscar. And again, the standard recursive formula. This time there is an initial accrued liability for 29 years of service as of the beginning of the year. There are mid-year exits. Those retiring at age 64.5 are actually accounting for the probability retiring at age 64.5, which is 1/2. And there is accrued liability at the end of the year equal to the present value of benefits of those who are retiring at age 65 in the context of Oscars. And we calculate now the beginning of the year accrued liability is 29 times 0.017, 1.7% for each year of service, times 95,000, and then this times 1/2 for retiring, a probability of retiring at age 64.5, times the cost per year, more or less, adjusted for probability and discount factor that results from each year, and adjusted for 29 years. So it's the probability of survival till retirement times discount factor times the cost of a unit life annuity at age 64.5. And then the same calculation, I had to split it into two lines, couldn't put it into one big brackets because there wouldn't be space, but it's the same factor in front of each of those two factors, quantities representing retirement at age 64.5 and then 65. So the second expression in brackets accounts for retirement at age 65, which happens with probability 1/2. And then we plug in all the quantities, do the calculation. This comes out to be 419,643.52. For the actuarial present value of mid-year exits, we assume that the last half year of service is counted for the number of years of service. So if you assumed otherwise, you would get a different answer. And that the salary over the last year of service is the average of 95,000 salary from age 63.5 to age 64, and 100,000 salary from age 64 to age 64.5. And again, different assumption, but this is the second one is definitely the most reasonable assumption. The first one depends on the nature of the contract, but this is what I'm assuming. So then the actuarial present value of mid-year exits is 29.5 years of service times 0.017 times that average salary times 0.5 probability of exiting times the probability of surviving to that point, cost of annuity, discount factor at 6%. And that comes out to be 224,827.462. And then the calculation of the actuarial present value of the accrued liability at the end of the year accounts for retiring at that moment. So it's 30 years of service now, times 1.7% per year of service, times 100,000 salary, times 1/2 for the probability of retiring, then probability of surviving to that time, cost of annuity divided by 1.06. And that comes out to be 222,462.18. Therefore, we have the following expression, that 419,643.52 plus normal cost is equal to 224,827.46 plus 222,462.18. And normal cost is the only unknown in this equation, and we calculate it to be approximately 27,646.12. Part D. For Finn, normal cost under projected unit credit will be higher. However, for Oscar, normal cost under projected unit credit will be lower. This is because for new employees like Finn, normal cost under traditional unit credit is typically lower than normal cost under projected unit credit, as PUC takes into account future salary increases. For each extra year of service, normal cost under traditional unit credit will only assume this year's salary increase over last year's. On the other hand, normal cost under projected unit credit will take into account the salary increases during the entire career to calculate the cost of an extra year of service. This typically means that one extra year of service is more costly under PUC than TUC for new hires, because they expect salary increases in the future. However, for employees close to retirement age, normal cost under traditional unit credit is typically higher than normal cost under projected unit credit. Here's the explanation of this. Under both funding methods, the initial liability is 0 for new hires. The ending liability is the same at the retirement age, assuming we are doing the calculation for the same case, only comparing the two methods. Normal cost under TUC is initially lower than PUC. Thus, to provide the same retirement benefit at the same retirement age, normal cost under TUC must be higher than normal cost under PUC during later years to make up the TUC funding shortfalls from the early years. You can also see this by noting that TUC effectively moves the funding costs for salary increases into the future, and this means normal costs in the future will have to increase, while under PUC, if salary increases match projections, such increases do not occur. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.